Good afternoon. I'm Rowan.
I'm Ria.
I'm Alex. Today we will present to you Data.Table, an R package that is known for faster subsetting, grouping, updating, order joining, as well as its short syntax. If you guys want to follow along with the code, open the video on your own computer, and in the description we have included a copy of the script and the datasets that we used. Feel free to follow along. To start off with, we will set the working directory as so. Next, we will install the Data.Table package. Now we will load the package into R. Now we want a dataset to play with, so we created one called homework.txt. We read the dataset in both as a data table and as a data frame for comparison. To create the new data table, we typed Data.Table and that read in the dataset as a data table. We can view both datasets by typing their names. They look identical. As you can see, there are 6 students with 4 homework scores each. If we want to sort our dataset by a specific column, all we would have to do is use Data.Table's setKey function. We chose to display this by sorting the values by student name. This function allows a data table to be sorted by a specific column. Note, we could have sorted by numeric values as well, or sorted on multiple columns. Now we can see that the data table has been organized alphabetically by student. The data frame method would have been to do this. What if we wanted to compute the average of their 4 homework grades and call it homework.average?
Homework.average is the name of the column we want to add, and to do so we type : equals. Next, we want to compute the mean of each row, so we use mean equals row mean. The next argument we use is .sd, which is meant to subset the given table the way we specify. Simply calling .sd subsets the data without the first column. Later, we use .sd calls and set it equal to homework 1 through homework 4 so that all the homework grades are included in computing the average. You can see that the new column is now included on our data table. For data frames, we would use. Similarly, the new column is also added to our original data frame. While the data table method looks more verbose, it allows us more options and processing speed than data frame, just like how vapply is faster than sapply in large data sets. Now we want to bring a new dataset that has the students' exam scores. We will store this in a data table called example.exam. We want to create an average column for the exams, so we will do the same thing as we did for the homework data frame. One of the great uses of the data table package is that it allows you to join together different data tables. We noticed that the homework dataset we used and the exam dataset we just introduced both have a student column. We can join both the frames by setting their keys equal to student. The syntax we use is an example of an inner join. We are essentially attaching example.table to example.exam on the student column and storing this new data table in a variable named final.grades.
If we needed to take a subset of a specific row, or student in our case, we could use the following syntax. For example, if Bob's parents wanted to know how Bob was doing, we could show them his grades. Unfortunately, his parents won't be too happy with his scores. Lastly, if we want to only show the homework average and exam average grades, then we could omit the other columns like so. Note that the only columns we can see are Bob's homework and exam averages. We have shown that data table has many applications, including subsetting, setKey, and computing the means of specific columns. For this project, we found the R documentation for data table to be very useful, as well as this webpage from DataCamp. Thank you for watching. This concludes our demonstration.